The photo on my title page here illustrates the beauty of Cowichan Valley. In this case, looking northward across Cowichan Lake. But you might notice that the photo is not quite pristine. For it also reveals human damage. And I'm referring to the south slopes of the mountains across the lake, where you see the results of earlier forestry clearing, clear cutting, many of which were not replanted, so that the soils got washed away in successive years on these slopes, leaving little more than bare rock. And the lesson here is that without government monitoring, a corporation concerned mainly with profit can take a huge toll out of the environment. And that's mostly what this talk is about then. So here are some recent examples. Are you seeing this?
Yes, go ahead.
Okay. Here's some very recent examples of the impacts of climate change. And those of you in Toronto, where this talk is being hosted, can relate to these first three photos, picturing some of the frustrations of flooding in Toronto last month. A potentially more serious impact occurred in Jasper National Park in Alberta less than a week later with a large out-of-control wildfire. We've been having more than our share of wildfires in Alberta and BC for the past decade. But on the evening of July the 22nd, the Yellowhead Highway was under threat from rapidly moving wildfires both northeast and south of Jasper. And that prompted Parks Canada to order the evacuation of just under 5,000 residents of the town of Jasper, plus some 20,000 campers who were in Jasper Park at 6 p.m. on the 22nd. The evacuation was carried out very orderly. Hours later, as that photo on the left there, you see cars leaving Jasper and then heading west. And despite the nearby visible flames that were there at that time, but less than 48 hours later, the wildfire moved rapidly into the town of Jasper, and soon 1/3 of the town was in flames, as the middle photo shows there. I got to move something out of the way here, okay. But no lives were lost at the time, thanks to the quick thinking fire marshals and Parks Canada. The last photo on the right is from Malign Lake, just south of Jasper, southeast of Jasper, following the burn through. And I want you to note that the wildfire did not fully burn the trees, even though it was a very hot fire. Now, typically forest fires spread through the needle canopy first on firs, along with some of the smaller branches and the underbrush, but usually leave the main trunks of trees intact, large trees at least. I'll come back to that again later because that's a very important fact. But the really worst impacts of the climate crisis have been felt in the subtropics, especially subtropical Africa. And we note first in the top of this graphic here that it is the mid-latitude industrial countries, Canada included in the US, Russia, Western Europe, who contribute the most greenhouse gases. And the tropics and subtropics are least responsible for those greenhouse gases. And then desertification caused by global warming means that the subtropical regions down in here are most impacted, get the worst impacts, because of prolonged droughts caused by the desertification, which leads to less arable land for agriculture, less water, and increased famines in almost every country, as this graph shows here. Most countries across the Sahel region of Africa have suffered through this, and over the past decade, the droughts have hit East Africa hard, and that's what I'm showing here for Ethiopia here. but Somalia and across the Horn of Africa in Yemen. I think you all know where that is, about there. Can you see my cursor here? You're muted, Amir.
No, we don't see your cursor.
You can?
No, we can't.
Oh, okay. So I'll have to talk and forget my cursor. So millions have died from famine, and many millions more, over 100 million, have been displaced to refugee camps in nearby countries. The accompanying text to this graphic here with this young boy, the accompanying text said he was not expected to live another 24 hours. But our Western media rarely report on the impact of the climate crisis in the tropics and subtropics. Okay, and then on tropical and subtropical oceans, these impacts are manifested in losses of corals and shellfish from overly warm sea surface temperatures and ocean acidification, the latter being caused by overabsorption of carbon dioxide by the oceans mixed with water to make carbonic acid. And both impacts will also cause eventual loss of fish. So I'm going to go on here. The underlying cause of most of human failures, including the climate crisis, is our unlimited growth, not just the exponential growth of the, of the population shown here, but everything that humans produce. And some examples include here, and I just picked a few at random: meat production, global domestic, gross domestic product, and the stock markets. They all show exponential growth, which is not natural. And as well as overuse of global fossil fuels, you see, is also exponential. Burning fossil fuels results in exponential growth of carbon emissions. And if this is a different scale than the one on the left here. And if I squeeze it up there, you'll see it has exactly the same shape as global fossil fuel use, which you'd expect. But I always wonder about emissions, whether we're getting the data right. But it appears that in this case it is. And besides that, you see how it relates to the atmospheric concentration of carbon dioxide. And it seems that humans have not yet learned that we can't have unlimited growth with limited resources. It's just simply not sustainable. So all of this, of course, leads to the climate problem of warming global mean temperatures, also on an exponential trend. I chose this graphic because it shows 5 of the main climate research labs around the world, most of them in the US. But you'll see that they're all basically the same. The only difference in the data they're using is the way they handle the data sparsity in the polar regions. And that gives you the difference. But there's general agreement that the trend in warming temperatures is approximately constant for this 50-year period from sometime in the late 60s up until 2015, and then something seemed to have happened, but we don't have enough data yet to prove it, but it appears that it's on a steeper trend there. We need another 10 to 15 years of data to prove whether or not that is on. We hope it's not, because it's headed to something else. But the main question is here, what are the risks that humans face in all of this? And recently, actually this past January, the World Economic Forum had their annual meeting, and they identified 3 major climate risks that we face. And these are extreme weather events, critical changes to Earth systems. We'll have to define what these critical changes are, and biodiversity loss. Now, earlier, the IPCC issued a similar warning, had these three on, but in place of number 2, they just called it generally climate change. And the World Forum was just trying to be more specific. So extreme weather events include major winter storms, flooding, such as Toronto just experienced, tornadic thunderstorms, and category 4 or 5 hurricanes. All of these most severe parts of the weather have become more prevalent in the past 20 years. And that inset satellite picture illustrates 5 tropical storms and hurricanes existing simultaneously, something that really didn't happen, or certainly not very often, prior to 25 years or so ago. So weather events like this are said to be in dynamic equilibrium. That is, they usually evolve where heat and moisture converges, putting the whole system out of balance. And then the storm forms in response to that buildup. The storm forming is just nature's way of restoring balance. And dynamic equilibrium occurs where the rate of gain of energy, you'll see here on that purple graphic, equals the rate of loss. And the system or storm moves away, generally poleward, dispersing the heat and moisture as it goes. And then as it decays, the system returns to normal, steadies out. Now, when we talk about critical changes to Earth systems, there's the possibility of our climate reaching a tipping point where the climate system undergoes permanent change. And I emphasize the word permanent. And that can occur when positive feedbacks occur simultaneously. And what we mean by positive feedbacks are things that lead to more warming, and the warming leads to more of that feedback, which leads to more warming, and you get into an indefinite cycle that doesn't seem to return. And if we get enough of those positive feedbacks occurring simultaneously, then we're in trouble, because it could start this tipping point, which is still theoretical. Nobody can prove this tipping point, but it seems to be the thing that we're headed towards. Now, nature always acts to restore equilibrium in any system. And so when we're talking about this kind of change, is where the rate of gain is greater than the rate of loss, and it continues to expand. And the system reaches a threshold or a tipping point where it can no longer maintain its character. So nature causes it to lurch to some new operational level, like that, to restore equilibrium. But the problem is that change is permanent. Now, the best example of that I can give you is an explosive volcano. When Mount St. Helens exploded in 1980, the mountain lost 500 meters off its top. So the system was changed forever. Although the system did reach equilibrium again, albeit at some higher level, presumably. The same could occur to our climate. These are the records since 1900 of global carbon emissions. Global carbon emissions. And you'll notice back before 1940, about 80 years ago, that it was not stable, but just about. In other words, up to that point, I mean, we had Arrhenius, the Swedish scientist, who proved mathematically that with increased global emissions, carbon emissions, the climate could warm. But we weren't seeing any trend in it until an American, actually, he was actually Canadian. He was born in Montreal, I found, but we call him American Guy Callender, proved the trend in 1934, somewhere in here. And then somewhere during the war years, it started to take off, the global emissions. So we went from what appears to be, it was in as near as possible, we can say, dynamic equilibrium. Back at that time, atmospheric atmospheric CO2 concentration was below 300 parts per million, but it and the global emissions took off about 1940. Now, the current atmospheric carbon, sorry, I'm going the wrong way here. The current atmospheric carbon dioxide holds the potential for climate warming of 3 to 5 degrees Celsius. With some experts, for example, James Hansen, arguably the most well-known climate scientist in the world, suggesting that it could reach 10 degrees C. And experts suggest that the tipping point could occur around 2 degrees warming. Again, there's nothing magic about that level, but it's what several experts have come up with, that at 2 degrees warming, we're really in trouble, which we could reach at current trends by 2040. Theoretically, it would then warm rapidly by several degrees more, and reach a permanent higher level of global temperature, which we could not reverse. Now, even 5 degrees Celsius warming would be terrible for our great-grandchildren, and I have 4 great-grandchildren myself now, but 10 degrees C, I'm pretty sure would be untenable for all mankind. We could not survive that. So we'll go on with biodiversity loss was the third thing that they identified. And biodiversity is declining rapidly. Now, this is something we don't notice because it's wildlife, and we don't really see that much wildlife, on a constant basis. But there's been almost a 70% decline in birds, fish, reptiles, and amphibians since 1970. And this photo here, just an example from 2021, when we had the heat dome over BC, tens of thousands of salmon were found dead after that drought period and heat dome in the Neches River. That's on the central BC coast. So the salmon population was wiped out from that river for that particular year. Few people realize the ongoing species extinctions, and some question why the concern. So I thought I'd throw that in there. Anyway, the health impacts of the climate crisis are often overlooked in heated discussions. In addition to the greenhouse gas emissions, you see at the top there, carbon dioxide, methane, and nitrous oxide, burning fossil fuels also release poisonous toxins to the atmosphere at the same time, including carbon down on the bottom right, carbon monoxide, sulfur dioxide, and various oxides of nitrogen, NOx. And these cause all manner of cancers as well as asthma. Wildfires also release arsenic into the air and water, and also these tiny particles, we've heard of them, PM 2.5 microns, that can easily get into our lungs, and they're small enough to stay there and cause lung cancer. And the World Health Organization and other agencies indicate that more than 8 million people die annually from fossil fuel pollutants. I can't prove that number for you, but there's a number of agencies that say it is so. So we are now in a war, or we should be, against climate change, not against nature, but against the anthropogenic part of climate change and against fossil fuels. And the question is then, what is Canada doing to help fight the climate crisis? What's the plan? So I can't go through the 79-page Canada's climate plan with you, but I wanted to mention the most important parts that I think of it. And they're listed here, these 6 actually, but these 5. Plant 2 billion new trees, the carbon tax, carbon pricing, cap and trade, and carbon capture and storage, or CCS. Now, those middle 3 actually all come under carbon pricing, but it's important to look at each one individually. So the climate plan has one major flaw, that when you look at these, you see the continued support for fossil fuels well past 2050. They include it in the plan, while it still claims to be countering carbon emissions. And I say that's a major contradiction in that. So these items here won't do anything substantial to counter carbon emissions in the time we have left before our climate reaches a tipping point, which could be 15 years or less. Now, I've published the details, we published the details of these in a CMOS bulletin in May there. So there's the link for it, you can check it. Also editorials in several newspapers, but these two in particular in the Ottawa Hills Times, because that's what MPs read, I'm told, the Ottawa Hill Times. So we had Richard Vanderjag and myself had these two articles in there. If you go to the Hill Times and get in there, you can search Strong, Jag, and these two articles will come up. There's one useful item that I find in the climate plan. That's number 6, that all new vehicles sold in Canada by 2035 must be full electric EVs. And so I wanted to go through these 6 items in some detail, but I'm afraid we'd need another seminar time to cover that. So I'll cover them as briefly as possible there. First, planting millions of trees. And I'll remind you, annual global carbon emissions are around 40 gigatons. And I like to write it out in full because it's 40 followed by 9 zeros. That's a lot of tons every year going into the atmosphere. The number of mature trees to counter even 10% of Canada's emissions, which are around 700 megatons, is this. So you'd need 1 billion mature trees, and I should emphasize the word mature, because what we plant when we plant trees are just tiny seedlings. And the amount of carbon in a tree is roughly half of its dry weight. So nothing happens with seedlings. In fact, I put together this little graphic here, which is the cumulative weight of carbon dioxide in tons in Douglas firs by year of growth. Okay, and so after 50 years, there's only about 0.4 tons in that tree, in a single tree. So, but we don't have 50 years to wait for these. So the bottom line is that planting many millions of trees cannot measurably counter current carbon emissions even after 2075. We still need to plant trees because that's one of the few things we have to help draw down carbon dioxide. But at present rates, it would take a couple of centuries to draw it back down to under 300 parts per million. Right now, I checked this morning, is at 425 parts per million. And so the next thing is the carbon tax. This started in 2020, and they increased it by $15 per ton every April the 1st to a maximum of $170 per ton by 2030. I can't relate to those numbers by ton, so I converted to cents per liter per year at the gasoline pump. So it goes up by 3 1/3 cents roughly for every liter that you buy at the gas pump. Now the average family, I learned from Wikipedia, drives about 15,000 kilometers a year, at least in Canada. And the cars run at about 10 liters per 100 kilometers, or converting that to 1 liter per 10 kilometers. So the added tax costs to the consumer works out to only about $1 per week, which is unlikely to convince people to reduce their driving, especially when you consider that regular winter to summer price increases by fossil fuels range from 30 cents in 2024, it went up there, at least here on the island, to more than $1 per liter extra in 2 years ago. And people don't seem to even notice that. They don't bat an eye at it. So vehicle traffic continues to increase with warmer weather. So I really don't think the carbon tax can do anything much as far as convincing people to reduce their driving. A few colleagues disagree with me. They seem to think that it does make a difference, but I reserve the right to say no. So we go to carbon pricing. And the way this works is that industry and businesses were given a target maximum for carbon emissions. If they exceed their target, they can buy carbon credits from someone, I suppose, downstream or something, who takes responsibility. In other words, they're passing the buck. And the carbon pricing does include the carbon tax. The federal government claimed an 8% reduction in emissions from, well, I get two different angles on this, from 2005 or from 2018. So that's out of the federal government, up to 2020. So how valid is that claim? So I want to go to that. This is the carbon pricing up to 2020. And they said there's an 8% reduction since the baseline year of 2005 to 2020. Or you can take it from 2018, so it's virtually the same thing, roughly 8% reduction. But it's all based on the fact that's the COVID year. And when industries shut down around the world for 1 to 3 months, and they didn't recover until the following year completely. And we notice in 2021, it went back up to 670, and in 2022 to 707. And the data hasn't been released yet for 2023. I'm guessing here that it's gone right back up to somewhere in that level there. Apparently that data won't be available till the end of this year. I don't know. So once again, that is nothing short of deliberate deception to use that. They know that that's the lowest it could go in that year, in the COVID year. It was very convenient for the government to show that, because they're really hanging a lot on carbon pricing. And again, my colleagues, a couple disagree with me on carbon pricing. They think it will make a difference. I don't think it will. It's not working as they claim, and it's unlikely to result in a significant reduction in carbon emissions. I should mention that the government used this trend here to say that they will reach 40% reduction by 2030. I think they'll be shown to be incorrect. And then there's cap and trade. And that's not worthy of me even looking at. It's just passing the buck on emissions, and so we won't cover it. But carbon capture and storage represents an even bigger deception, because it appears to be the flagship of the federal climate plan. So let's review a few facts there. First of all, there are some between 20 and 30 operational CCS facilities globally, mostly in North America, each year since 2008, at least back that far. And every year since then, they claim hundreds more are under construction, but they're not. In fact, today I checked, a couple of days ago, there are 23 still operational now, including one north of Edmonton that Shell Oil created. And they just released an announcement in May that they were shutting it down for good because it wasn't economically feasible. Now that should tell you a lot right there. They don't think it's feasible. So most of these were constructed with government grants in both Canada and the US, but they are fully owned, operated, and reported by the fossil fuel industry with little or no government oversight. And most of them claim they can increase carbon capture to 1 million tons per year, but all of them pipe the carbon dioxide away to oil and gas fields, where they pump it underneath the field to improve the efficiency of the field. Meanwhile, what do you think happens to that carbon dioxide that they pump down there? Eventually, it makes its way to the top again, back into the atmosphere. So there's no net change. But let's just assume for a moment that they do capture 1 million tons per year. And again, reminding you of 40 gigatons of annual carbon emissions. What could it do? The number of facilities required to counter global carbon emissions is a very simple calculation. You'd need 40,000 facilities or 4,000 to counter 10% of emissions. Nobody is going to build that many facilities. There's still only 23. So the bottom line is that CCS is not working, and yet the government has put a lot of money and time into it. So next is this way forward that I had on my title page with renewable clean energy. But first of all, I have to digress for a moment to look at carbon emissions from wildfires. It's important in the overall context. Back in August last year, there were claims that carbon emissions from Canada's wildfires were 50 to 100% of total annual emissions from all other sources. That disinformation item, because that's what it is, may have come from either the fossil fuel industry or big government. I think from the fossil fuel industry, in an attempt to deflect attention away from the burning of fossil fuels. It works great for PR, right? But if you look at the Jasper Park wildfire in July, this is one in the beginning stages, you see that, there'd be a big burn area they would calculate, but you see the burn areas are sporadic. There's areas here that are still green. And even within the burn area, there are trees that don't get completely burned. And you've probably noticed that yourself if you've been in around where there have been forest fires. Here's the Jasper Park burn area here, or part of it. And what we see, if I can go to my notes again, that not all the wood is consumed by the fire, obviously. It goes through the needle canopy, burns it rapidly, and some of the smaller branches, but even some of the larger branches are left here standing. I did a survey of my own of the forest fire that wiped out the town of Lytton, BC in July of, no, it was the end of June of 2021. And there were areas where they piled up some of the logs, I presume, for their individuals, collecting them to so they can heat their homes with wood burning. But you'll notice these logs, the bark is scarred from the burn, but the wood actually looks quite good. Now, I'd need a forestry expert to confirm this, but to me, these look like they were, some of the larger logs would be salvageable for making lumber rather than cutting down clear cutting another whole area of forest. So tree trunks like these following a forest fire can probably be harvested instead of being left to rot while emitting its carbon back to the atmosphere. I don't mean everything you pick up in the forest, because you want to leave some of it to rot to restore the soils, but not all of these logs. So let's go to then a way forward. And Amir, I'm going to ask you to let me know when I got 5 minutes left of the 45 you allocated. I don't think we're there yet, are we?
Okay, well, it's 12:45 now, so go ahead. We have a lot of time.
Well, we wasted a lot of time to start there, I'm afraid. But so renewable clean energy to replace 90 to 95% of fossil fuels over the next 15 years. In other words, electrify almost everything. So renewable energy consists of these things. They're all sourced from the sun, ultimately. Although the sun may only last another 2 billion years, so we better hurry up. And the energy is free. We just have to harness it and convert it to electricity. The key thing about renewable energy is that no new technology development is necessary. All have been in use for hundreds of years, except for the converting to electricity, perhaps. So here's a solar farm from southern Alberta. And Just a second. There, and Premier Smith of Alberta, in her great wisdom, set the guidelines so stiff that everyone gave up building them. So there's no more construction of solar or wind towers in Alberta at the moment. Here's a wind farm. Now, a lot of some people suggest that these are not aesthetically pleasing, and they might have a point, although they don't bother me. But for those people, I would suggest that they look at Fort McMurray oil sands for something aesthetically more pleasing to them. Home-sized geothermal is worth doing if someone is building a new home with a basement. You might as well build this in as well, because these piping for home-sized geothermal only needs to be 6 to 8 feet below ground, and so it gives you heating in the wintertime and cooling in the summertime if you combine it with a heat pump. So how should a national policy on renewable energy proceed? Fossil fuels, you have to recognize, are a huge monopoly, and they directly or indirectly swamp much of the Earth's resources. They release carbon emissions while burning and pollutants, which warms the atmosphere while poisoning every living creature on Earth. Worse, if left unchecked, our climate could reach this tipping point within 15 years, after which it would move more quickly to a stable level, around 5 degrees Celsius warming at least, some say up to 10, and we could no longer reverse the process. That's the key thing about a tipping point. So we're now in this war against climate change, but if you go about it in a big way with renewables, you could not survive an open war with fossil fuels because they have far more money and power. So you'd be probably wiped out. So consider then how in history, how small armies often survived wars against much bigger opponents. I'm digressing again a bit here. I'm looking at Hannibal, General Hannibal from Carthage, who defeated the much larger Roman army in 215 BC by flanking the enemy. This is a picture that I get from it. The Romans would line up their troops in lines like this, whereas Hannibal's troops were lined up in loose V formation like this. So Hannibal is looking at this from his camp across the river here, and he sees there are some 86,000 Roman troops, and he had less than 40,000. So he knew, I'm going to lose this. We're going to lose this badly. But he quickly got word over to his generals here, and he said, I want you to straighten out those lines, make them longer than Roman lines, and then take some of the troops, bring them in behind behind the Roman troops. And there's nothing more debilitating or frightening to a soldier but to know he's being shot at from both front and rear. So they became very disorganized, and the Carthaginian troops just simply overran them and killed 80,000 of the Roman troops, including all of their generals. So that's a lesson learned. So how can we apply this flanking tactic against fossil fuels? Well, you work with small-scale renewable microgrids for individuals, and we have lots of examples of that around, or mesogrids, I'm calling it, at municipal levels. So you set them up all around, and then you can start linking them together for mutual security, or even tie them into the main provincial grids. And encourage small industry to switch to electric energy. That's not so difficult as it might sound, because these small businesses, they understand economics, and they'll figure out very quickly that electric energy is a lot cheaper, and if it's available to them, you go with that. That starts to draw resources away from fossil fuels all around. Then market forces take over, and the fossil fuel demand shrinks, and fossil fuels then reduce the supply, and eventually carbon emissions are reduced. Instead of the reverse, that a lot of environmental agencies are saying, we want the government to mandate all, fossil fuels to cap their emissions. In other words, stop the supply first and then the demand shrinks. Well, that's the wrong order. This is the way that market forces look at it. The demand shrinks and then they force the supply. So you don't get involved at all with fossil fuels. You basically ignore them. In other words, think global and act local. Federal and provincial government roles should be at arm's length. We don't want government coming in, organizing and administering something like this. It would go on for years before they'd be ready if they did. But we need government leadership to first stop all subsidies to fossil fuels. That's a big one. And then fully embrace renewable clean energy. They say they're behind renewable clean energy, but they haven't put much money into it. Provide subsidies to small businesses or public groups developing a mesogrid, and then work with provincial governments, and that's where some of the difficulty will come up, to upgrade major electric grids and put them west-east rather than north-south the way they are today. And encourage industries to convert to electricity from fossil fuels. Is much cheaper with less maintenance. And to ensure cross-training courses be arranged for workers switching from fossil fuel jobs into renewables. And note that any new hydroelectric systems, we don't want any more big dams. They should be small scale, run of river type of small hydro generators. And something of this size could be integrated into a mesogrid, assuming they have a nearby river flow. Other advantages are that each mesogrid can be operated independently with its own battery storage or linked with others. And it's trifling easy to expand a mesogrid, simply adding more solar or wind with no disruption in the energy while they're doing it. There's less energy loss over smaller distances, depending on the voltage. High voltage means less loss. And what can individuals do? I'm not going to go through all this list, but I will mention this one for people to canvass municipal governments to mandate new residential and commercial developments to be full electric. We did that with North Cowichan on the island here 2 years ago, and they did mandate that any new residential or commercial developments have to be full electric. And so this is a big one, supporting youth environmental demonstration. It sounds like not very important. And yet politicians follow youth because they know they're the next voters, right? And youth demonstrations are generally peaceful, nonviolent. I haven't heard of a violent one yet, unlike when adults get involved and then problems start. And why support youth? Because it's their future, not ours. I got a scriptural context to this from the book of Genesis. God put the man in the Garden of Eden, which is really all of earth, to tend and keep it, allowing for evolution. All it means is that we're here to respect our environment and to look after it for future generations. That's all that says. So in summary, renewables are a practical way forward on the climate crisis. We need to develop them not through big government or corporations, but at small local scales and mesogrids. They can be easily expanded, scaled up. They can be a link to the major electric grid. And I invite everyone to, whenever you're talking to an MP or your MLA or a municipal councillor, to ensure they're on side with replacing fossil fuels with renewables. If they're not, remind them that you're a voter. And don't fight fossil fuels directly. Let the market forces reduce fossil fuel demand. And I got a quote here from a great philosopher in 350 BC. Socrates said, "The secret to change is to focus all of your energy, not by fighting the old, in this case, fossil fuels, but on building the new, renewables." So you ignore fossil fuels. And that's how we can fight the climate crisis. And borrowing a quote from Apollo 13, failure is not an option. So if you decide, this is the last slide, as some have expressed, that Canada is probably the safest country in the world from climate change, and so I'm not going to bother worrying about other countries and that, that's a little bit like this cartoon. where these chaps are saying, sure glad the hole isn't at our end, but we're all in the same boat. And in terms of the climate, we're all on the same planet. And I don't know why there isn't more cooperation on this. Instead, we have more wars. But anyway, again, think global, act local.
Okay. Thank you, Geoff.
I'm going to take off.
We'll open it up for questions. You can either post it on chat or you can speak.
Not sure how to do that. Chat.
Okay, on the chat, I see a few comments. One says that can you sell the federal government just a little tiny bit short? You sell the federal government just a little bit tiny short. In 2022 plan includes support for EV. I guess biodiversity is policy thinking. I can't read all of it either.
Why don't we let that person speak for themselves and
Yeah. Okay, is John Hollins?
have on mute.
You may be on mute, John.
Is he still there?
I don't know.
Sure, I'm still here, but
Okay.
I'm not used to this form of Zoom. Perhaps I'm like Geoff. I know another form. Look, Geoff, what you sold the federal government just a little tiny bit short. They've actually included in their 2022 plan support for EVs, which is one of the recipes in your recipe for what individuals could do, which frankly is
I
the
took advantage of it back last November and bought an EV and got their rebate.
But the real issue, it's a policy issue. And our federal government has had available to it for something like 4 decades energy systems analysis, taking account of science, technology, and not just old-fashioned traditional economics. So the real place that needs to change is the federal policy. It has to be led by the federal government, in my view. And I don't see any sign of the current crowd understanding, and I really doubt whether the next crowd is going to understand as well. What do you think? Do you see any prospects for federal progress on this file? Real progress, not just fiddling around on the margins?
No, well, I tried to impress how their policy is supporting fossil fuels right through to 2050. They have to get out of that altogether. Otherwise, their plan cannot work. So I don't see how we convince them of that. I've written 4 letters to the Prime Minister in the last 2 years. All I get is replies, a generic reply from one of the secretaries, of course, but I don't know if they really actually pay attention to it.
It's really frustrating to be a citizen like the folks on this call who have some grasp of the issue, but we're not politically connected. An MP typically gets 200-300 emails a day. They're obviously screened by staff. Your chance of actually getting through into the political process is modest. Frankly, the trains left the station on climate change. As far as I'm concerned, it's on a downward slope, gaining speed. What's your optimistic view of where Canada and the world is going?
Well, first of all, it's useless to send an email to an MP because, like you said, they get so many. So the letters I've written, I always send by registered post. So I know when the thing arrives and when it's open. And I encourage other people, if they're writing to an MP or the Prime Minister, to do likewise. But Realistically, I try to put on a straight face and say I'm hopeful. And the only reason I do this is because I've got 4 great grandchildren. And I wonder what kind of life they'll have when they reach 30 in the early 2050s. And to be honest, I think we're in serious trouble. Unless there's a serious move by government to change their policy and stop the support to fossil fuels. They're not serious about it.
May I ask a question? No,
Sure.
this isn't a question. You haven't said anything about nuclear power. Scalable, emissions free. Why not?
Well, very
That's a
simply
question.
because to put in any more nuclear power, it would take about 10 years. There's
Okay, you said you had 15.
let me finish. There's environmental reviews. They have to construct it. They have to test it. They have to assure people in the area that it's going to be safe. Whereas renewable energy, you can put a whole setup up in a few months. So, and of
There's
course, there's
environmental
always
reviews for
safety
wind
issue
farms
concerned.
too.
I'm sorry, there's always the safety issue concerned about nuclear power that I don't deny it. I mean, but I'm leery of it. So
I give up. There's always environmental reviews and delays in the 10-year direction for a wind farm too. Try it in rural Ontario.
yeah, but it's not as stiff as for nuclear. And for solar, I don't think there are any environmental reviews other than having the land and saying this is what I'm going to use it for. But I'm no expert on that. But
Okay, I think there are some few other people who have raised their hands. Can they go ahead and ask questions?
you better identify them and let them take their turn.
Okay. Know where they are.
Okay.
Richard,
Yeah.
no.
That's fine. Thank you. Great talk, Geoff. I just wanted to recognize, people need to recognize that supporting carbon capture, which the government does, is as another means of allowing the fossil fuel industry to just continue unabated and actually increase production without actually putting money into renewables. I just wish they'd take the money from carbon capture and put it into renewables. That would be a really good start. But the next question is, which level of government do you approach first? The federal government, the provincial government? Personally, I think it's the federal government that you go to, but then whom do you go to? It's really, as you've already pointed out, it's very hard to go and to get through to them. But I really wish we would do that. So
it has to be federal government first.
Mm-hmm.
Because I mean, we're talking about a global issue, not a local issue. We can't solve the climate crisis on Vancouver Island alone or something like that, right? So
no.
If you could only get government leaders talking together and agreeing, but there's the problem, isn't it?
Yeah, and the other issue is that they although the government has supported, the federal government supported EVs, they're not putting in the grid to support them, and that stopped a lot of people from buying EVs, and I don't think that's recognized either.
Well, I bought my EV in November. I already know that I'm going to save $3,000 to $3,400 a year on fuel cost alone. And I drive about 20,000 kilometers a year. So
I agree with you. We have an EV too, and we're perfectly happy with it. But a lot of people they're still they have range anxiety, and they're not going to buy the EV until more charging stations are put in.
Yeah, if you eventually have to replace your vehicle, you'd be foolish not to buy an EV, because just from the economic standpoint of what you can save with it on fuel and on maintenance costs, that sort of thing. So
Okay, I think Zach has another question. Is that right?
Zach?
Zach Jacobson? Or maybe not.
No, that was my question. But while you're on it, somebody has to fire up an EV. And except for places like Quebec, Ontario, and I think some BC, almost all of that power that will drive an EV will come from a fossil fuel generator somewhere. So
No,
I don't think EVs are a magic bullet.
not if we have renewable energy being, and it's on the increase, it's obvious, but here's a question for you. If you support nuclear, would you be happy if they put up a nuclear energy system right next door to you?
Absolutely. I would be delighted.
Well, you're among the minority.
Unfortunately.
Okay, well, any other questions from the audience? Okay, Edward.
Can I signal my intention? I don't know how to do it the other way. Geoff, very quickly, the Hannibal strategy, I really enjoyed that metaphor, but it only worked because Hannibal was their leader. If the individual soldiers in Hannibal's army said, "Oh, let's just do it ourselves," I doubt. But I'm no war strategist. In any event, what I'm trying to say is, where is our modern Hannibal? You are trying to be Hannibal, but he was a bit younger than you, I think. So who's going to lead this fight in Canada? Do you see someone taking this over?
Well, I think you've hit upon, right now we have very poor leadership in government, right? In both the US and Canada. I think that's going to change with Kamala. And maybe if Mr. Trudeau would decide to retire and they pick a better leader, you know, that could run things. I don't know. That's a problem. Is leadership, as you pointed out, isn't it? Anyone else?
Okay, one quick comment from me, you allow me, and that is the resident time of CO2 is very long, decades. And even if you put all of these measures in place, it will still continue to, the temperature will still continue to increase. And we may, you know, pass that tripping point that you mentioned earlier. So can you comment on that, please?
Yeah. Is right. I mean, maybe this started in 2015, like that diagram I showed you. I don't know. I hope not. But we're definitely over that 1.5 level. That's no longer valid to try and keep emissions down to that level. What was the first part of your question? The question there.
Well, I was thinking that, you know, the resident time of CO2 is still very long, and even with these measures that you have mentioned, the temperature will continue to climb because the CO2 is still in our atmosphere.
Yeah.
And so, you know, tipping point will be reached even if you have all these measures in place.
It's quite possible. And you've hit upon, that's one of the things that government leaders and probably industry don't understand, that the climate warming we get, say, this year is not due to the carbon emissions this year, is due to the cumulative emissions of the last 100 years. And so if you stopped all emissions today, like you say, the climate would continue to warm, albeit at an increasingly slower rate. But we could still hit that tipping point. Yeah, that's the danger. But we've had enough warnings of it, and they're not paying attention. I think all of the climate plans that were summarized in the IPCC report, AR6 report last year, indicated that people think that if they keep emissions at today's level, that it won't warm anymore. Nothing could be further from the truth, of course.
Okay, if there are no other questions, then the only thing left for me is to thank Geoff. Very informative and new ideas in your presentation. Let's see if the federal government responds to any suggestions. So thank you very much, and it was a lively presentation.
Thank you
Thanks everyone for joining.
for suggesting the talk. I'm quite happy to do that. Okay. I don't have my full screen back here, so I can't opt out.
Okay, Geoff, I will end the meeting now.
Okay, thanks.